All right, how about problems about distance, rate, and time? Well, anytime you've got a problem with distance, rate, and time, you got to be thinking about distance equals rate times time, the good old, standby formula that you're going to use all the time. Let's put it into service here. A jet flew from New York to Los Angeles, distance of 4,200 kilometers. The speed for the return trip was 100 kilometers faster than the outbound speed. If the total trip took 13 hours of flying time, what was the jet speed from New York to Los Angeles? All right, so we read it all the way through. We identified what type of question it is. It's definitely a distance equals rate times time question because it's talking about distances, rates, and times. Now we can identify the variable. It wants to know what was its speed from New York to Los Angeles. So S is going to be the speed from New York to Los Angeles. I'm going to draw a picture. So here's LA, right? Here's New York. It flew from New York to Los Angeles and then back to New York. And it wants to know what was the jet speed from New York to Los Angeles. So it's looking for the speed along that trip. Now the speed, so it says a jet flew from New York to Los Angeles. So this is our first trip. And then the speed for the return trip was 100 faster. So doesn't that mean on this one we went S plus 100? If the total trip took 13 hours of flying time, and we know the distance, right? We can figure everything out from this. So distance equals rate times time. Or, since we don't know the rate, maybe we want to solve for that, right? Distance equals rate times time. We don't know speed, right? We don't know time, right? So we could think of rate equals distance over time, or we could think of time equals distance over rate. There's all sorts of ways you can play around with this formula depending on the information you have. Well, here we have distance and we kind of have speed, but we don't know anything about the time. So we'd want to go ahead and solve for time and say time equals distance over rate, and that's where we get this one. And then the same thing down here, right? Distance over rate, and that's where we get that one. All right, now what do we know about those two times? Well, hopefully you're all screaming at the screen. We know that they have to add up to be 13 because it said the total trip took 13 hours. So that time plus that time equals 13. We put in our two formulas. 4,200 over S, blah, 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 equals 13. You're going, oh no, more fractions. But remember, the rules never change. When we have fractions, multiply by our denominators. Now, instead of thinking of a common denominator, do it in pieces. Multiply this by S and this by S. And you kill off the first fraction. You get 4,200 plus 4,200S over S plus 100, right, equals 13S. Now, we still have this bottom, so we're going to multiply everything by that, and we're going to get 4,200, right, times S plus 100 plus 4,200S, because these will just cancel, right, when you multiply by S plus 100, equals 13S times S plus 100. Now your fractions are gone, and now it should look a little better. All right, so here's where we're at. Now we do a little math. We distribute the 4,200 times the S plus 100, and this gives us 4,200S plus 4,200S gives us 8,400 of them, right? Then we do 4,200 times 100, and there's 420,000. Then we do this distribution, and we get 13S squared, and then 13S times 100 is your 1300S. All right, now we see that we have a squared piece and a linear term and a constant. We're thinking, well, it's a quadratic. We got to solve it as a quadratic, which means we got to put everything on one side so that equal to 0. So We bring both of these two pieces over, combine this one and this one for your 71. This becomes negative. And then there's our quadratic. Now, this equation does in fact factor, but it's kind of hard to figure out what those numbers are, so it's probably a lot easier to just use the quadratic formula in a calculator. And when you do that, you get 600 or negative 53.8. Now, since S represents speed, we throw out the negative number because, yes, I know in physics a negative speed just means speed in a different direction, but that's not really speed, that's velocity, right? And we weren't talking about velocity, we were talking about speed. And when we talk about speed, going left and right or up and down, your speed is still positive. So you can't have a negative speed. So we throw that out, and our answer is 600.